based questions. So this is competency focused practice questions for physics 12 class 12 and volume 2. Let's begin and explore, understand how competency based questions are and how we can solve these competency based questions. Okay, so let's start with the first question. The first question is on capacitance. So you all know that capacitance and capacitor related questions are really important in class 12 physics. So first question is, the capacitance of a capacitor is C naught. So this means that the capacitance, what is capacitance? Capacitance is the ability of the capacitor to store the charge. Ability to store the charge, that is called as what? Capacitance. So capacitor is a device normally which used to store the charges. So and the initial capacitance is C naught. So let's draw a diagram. So there is a capacitor and initial capacitance is C naught, and which is connected to a battery voltage. So we have a battery voltage that we are provided is V. So the first line is done. So why we provide the battery? So that it charges the capacitor. So it's done. Now when the capacitor is still connected to the battery, so what does it mean? Still the battery is connected. So underline, still the battery is connected. A slab of dielectric material is introduced between the plates. So this means in between the plates of a capacitor we are going to introduce a dielectric. So this is a question. And now what we have to find? Which of the following explains the effect of this dielectric? Okay, so that means when you introduce the dielectrics, what is the effect of this dielectric in the above situations? So 4 options are given to you. So we'll see one by one. Take your own time in understanding. So let's start the basic things. You know, for a capacitor, the charge stored in the capacitor is Q equal to C naught into the potential difference. So here C naught is what your initial capacitance, V is the potential difference that we have provided. And as you know that when you introduce a capacitance dielectric in between the plates of a capacitor, the capacitance is increased by K times, isn't it? What is K stands here? K is what? The dielectric constant, and K value should be greater than 1. Okay, so this is the first line. When you charge is C naught into V, that is the initial charge. When I am introducing, the capacitance is increased by C equal to K into C naught. But over here, one thing you have to remember, that you have to notice over here is the battery still remains the same, right? The battery voltage is not going to change. Yes or no? So what does this mean? The new charge introduced between the capacitors, we can write as Q dash, is equal to, what's the formula? New capacitance. And what about the battery voltage? Voltage is not going to change, that you can write as V. As earlier we have written for V. Initial charge is equal to C naught into V. Same way right now the charge Q dash is equal to new capacitance C into V. So what is C stands here? New capacitance, right? Which is increased by K times initial value into V. This is the new charge. Q dash is equal to, so we can write Q dash is equal to K into, what is C V naught? You already know that C V naught equal to Q. So we can write the charge is increased by Q dash is equal to K into Q. So these are the basic things you have to know about it. Now let's go ahead with the options provided to you. The electric field between the plates of the capacitor rises. And as you know that is electric field depends on the potential difference and the distance between the plates. So here nothing is mentioned about the changes in the distance between the plate. Even they mentioned that the potential difference remains the same. What does this means? This means that electric field remains the same. Electric field remains constant. Here they said increases. So this option is wrong. So once again I am telling you, electric field depends on the potential difference and distance between the plate. So since the battery voltage constant and the separation D is also remains the same, So we can say that E remains constant. So the electric field is not increases. That's done. Now come back to option B. They said that potential difference between the plate increases. How? Because the battery maintains the potential difference. Who is maintaining potential difference? Battery maintains potential difference. So here they said the potential difference between the plate falls, and over here we are already still it is connected to the same battery. What does it mean? This means that potential difference remains the same, but here they said it falls. So this is also what is it? It's wrong. Now come back to the next one. The total charge on the capacitor increases. Is it correct? Yes, we have already derived it. Is it? Total charge Q dash is equal to Q K into Q. So that means total charge increases. Now the ability of the capacitor to store the charges. What is the definition for capacitance? Capacitance is the ability of the capacitor to store the charges. So by introducing a dielectric, actually this ability is increasing, but over here the option given is decreasing. So this option also seems wrong. So what is the correct answer to the first question? The total charge on the capacitor increases. Why A is wrong? Because electric field is here in this case same as potential difference, and the distance between the plates remains the same. Now why B is wrong? Because potential difference falls, they said, but since we are keeping the battery voltage same, because since battery maintains the potential difference, so hence in this question we are maintaining the same batteries, the potential remains the same, not false. The last one, ability of the capacitor to store the charge decreases. As you know that what is ability to store the charge, which is called capacitance. So here the capacitance is increasing, increase by introducing the dielectric. Okay, so this is about what we can say, the first question. So if you want, I can conclude with a small, memory one. You have to remember. So what we can say, when the potential difference, if you are keeping as constant, you can say that capacitance increases, charge also increases, but electric field remains constant, that we studied. And the second one, this is for battery, constant battery. But what if a battery is, you are disconnected? Okay, so if you disconnected the battery, what will happen? Q is constant, okay, and then capacitance increases, but voltage, what happened? It is decrease. So is it clear about the capacitance? Okay, so now we come back to the next question. Next is, the image below shows two examples of electric field lines. Two field lines are given to you, and they are asking which of the following statements are true. So as you know that, since parallel lines and equal spacing, immediately you will write this is what a uniform electric field, right? Or we can say a constant electric field. Second point, here in the second diagram, here the field lines are further apart, right? Widely spaced lines. So this means that these are the regions of weak electric field. And what about when it is closely packed lines? These are what? Strong electric field regions. Okay, this much is clear from the diagram. Parallel lines with equal spacing. Now next point you have to remember, if it is a positive charge, electric field lines start from positive and ends in negative. So these are the three key points you have to remember. Okay, what is it? Field lines start from positive and ends in negative. How to represent a uniform electric field lines? Parallel lines with equal spacing. And what about weak electric field lines? Okay, how? Weak means widely spaced lines. And what about strong electric field? Closely packed lines. Okay, so we can go ahead with the first option. The electric field in both 1 and 2 arises due to a positive charge, a single positive charge located somewhere on the left. So you know that the diagram is clear. Maybe the positive charges are here, and it's from the left, because electric field lines start from positive and end in negative. But one problem over here is They said that it is a single positive charge. And you know that for a single positive charge, electric field lines are radially outward. What is it? They are what? Radially outward. So here it is not radially outward. So the first option seems wrong. Second one, the electric field lines in 1 and 2 can be created by a negative charge somewhere located on the left and the positive charge somewhere on the right. So that's wrong, because from the diagram you can know electric field lines start from positive charge and they end on negative charge. So if the positive charge is on the right hand side and the negative charge is on the left hand side, field line should start, is to go from right to left. But in this case, it goes from left to right. So this statement doesn't match with the diagram shown in the diagram. Okay, so that is also wrong. So now we come back to option 3. Electric field in 1 is same everywhere, but in the electric field in 2 becomes stronger as moved towards the right. Is it correct? Yes, because on the right hand side this is a uniform electric field in 1, but you over here towards the right, what happened? The field lines become stronger. How come you will say that it is stronger? Because they are crowded here. So this option is correct. And the last one, as you move from left to right, the field lines both one end become stronger. No, because in the option 1 you can see they are parallel lines with equal spacing. So that is what? Uniform. So that also wrong. So the correct answer is option C. So what we have learned over here, we learned 3 points. If it is an uniform electric field, that is represented by parallel lines with equal spacing. Second, what did I said? Weaker means the field lines are separated out, and the stronger field shows the field lines are crowded. And field lines for a positive charge is radially outward. And what's the direction of the electric field line? Start from positive, and where does it goes? It goes in negative charge. So I hope second question is also clear. Now we come back to the third one. So the third question is, you should know about differentiation. I hope you all know about it. So let's start. In the given region, the potential difference varies with position is given by V of x is equal to 3 plus 2x square. Identify which of the following statement is correct. Okay, first one, the potential difference between the points x is equal to 2 and x is equal to minus 2 is 2 volt. Let's start. So this is your potential difference, which is equal to 3 plus 2x square. As you see here, potential difference varies with distance. They said put x is equal to 2. So substitute v equal to 3 plus 2 into 2 square, isn't it? So 3 plus 2 square, okay, 8 into 2. Is it correct? Yeah. So 3 plus 2x square. So we got us how much? 3 plus 4 into 2 is 8. 8 plus 3 is what? 11. So when you substituted v of 2, we got 11. And let's see what about minus 2. So minus 2 also the same, plus 2 into minus 2 the whole square. So you are getting 11. Okay. So but they are asking difference you have to take. So v2 minus 2, so 11 minus 11, so which is equal to 0. But here in this option they said that the value should be 2. So wrong, because 11 minus 11, so v of 2 minus v of minus 2 is 11 minus 11, which is equal to 0. But here in this option they said that 2 volt. That's wrong. Okay, so first option is wrong. Second one, a charge of 1 coulomb placed at x is equal to 2 experience a force. So that means you have to find the value of the force. So how to find the value of the force if you have potential difference with you? So what's the formula? You all know about it, right? What's the formula? E equal to minus of dv over dx. Let's differentiate. So you will get E equal to 3 plus 2x square, which is equal to, how much it is? 4x, but minus 4x. Now you can find the force. What is the formula for force? Force F is equal to QE. Right? Q value, as they said, 1 coulomb. So 1 into electric field is minus 4x. So force F is equal to, what is the formula? Minus 4x. And they are asking When x is equal to 2, what is the force? Let's see. F is equal to minus 4 when x is equal to 2. So answer is minus 8 Newton. But in the given question they said as 6 Newton. So that is also wrong. Now the force experienced by the above charge is along positive x-axis. Since as you see here the value of force you got is what? Negative, right? Okay, negative x-axis. But here the negative indicates that electric field is along the negative x-axis. So if the electric field is along negative x-axis, then if force is also negative x-axis. So this is also seems it's wrong. Next, electric field in the region is a non-uniform. Is it non-uniform? Yes. Why non-uniform? As you see here, the electric field is given by E equal to minus of 4x. So the electric field depends on the distance, isn't it? So as the distance varies, what happened to the electric field? Electric field also, varies. So at different positions, the value of E changes. Therefore, we can say that electric field is non-uniform. Okay, so now we can go ahead with some memory trick. How to remember? If potential difference is directly proportional to distance, isn't it? So this means, okay, so what does it mean? Then we can write E equal to dV divided by dx. So that means electric field is a constant. But V is proportional to x square. Then what is E is not constant, E varies. That means electric field varies. This means that it's a non-uniform electric field. Okay. So this is about the second question. So what all the theory part we have learned here? That the relation between the electric field and potential E is equal to minus dV by dx. Negative sign shows that electric field is along x-axis. Since electric field depends on distance, so that means as the distance varies, electric field also varies. So this is a non-uniform electric field. And what's the relation between force and electric field? F is equal to Q into E. So I hope these three questions are clear to you, and then you can start practicing.